In this numerical, 0.7 grams of a sample of hydrated sodium carbonate was dissolved in water and the solution was made to 100 ml. And 20 ml of this solution required 19.8 milliliters of 1 by 10 normal HCl for complete neutralization. And we need to find out the X value in the hydrated sodium carbonate formula. Now, as this is a neutralization reaction, one is hydrated sodium carbonate and other one hydrochloric acid. So definitely the number of equivalents of this hydrated sodium carbonate solution should be equal to the number of equivalents of hydrochloric acid, isn't it? Means the normality into volume of hydrated sodium carbonate solution is equal to normality into volume of hydrochloric acid solution, or I can write it as N1V1 is equal to N2V2, a very famous formula. So now, what is the normality and volume of hydrochloric acid given? It is given as 19.8 milliliters of 1 by 10 normal hydrochloric acid, means 0.1 normal hydrochloric acid solution, and volume is 19.8 ml. And what is the volume of this hydrated sodium carbonate solution taken? It is 20 ml. 20 ml of this particular solution. Why they use the term this solution? Because the concentration of hydrated sodium carbonate is not given. So we need to calculate from the given data. So here we need to use the basic formula of normality, that normality is equal to mass of the substance divided by gram equivalent mass into 1000 by volume of the solution in milliliters, isn't it? So the mass of the substance is given as 0.7 divided by gram equivalent mass. As we don't know the molecular mass of this hydrated sodium carbonate, let me write it as gram molecular mass divided by the X factor. And for the sodium carbonate, we know that X factor value is equal to 2. So this is weight upon gram equivalent mass multiplied by 1000 divided by volume in milliliters, which is equal to 100. So here no need to divide both these values by 1000 to convert the volume into liters. Whether we take number of equivalents or number of milli equivalents of both the compounds, it is the same, because if you want to express the volume in liters on both the sides, we need to divide by 1000. Anyhow, that will be cancelled out. So on solving this, we will be getting the gram molecular mass of this hydrated salt as equal to 141.4 grams. So if the molecular mass of Na2CO3 x H2O is equal to 141.4, it means that 106 plus x into 18, this is equal to 141.4, isn't it? This is the molecular mass of Na2CO3 and x number of water molecules are there. So the molecular mass of water is 18 multiplied by x. So now on solving, we will be getting the x value is equal to 2. So that is the reason why our answer is option B. Is it clear? Remember, whenever two different substances are reacting with each other, they always react in the ratio of their equivalence. So equivalence of one substance should be always equal to equivalence of the other substance.